Hello dear students, in this video I'll start with 7th unit Financial Mathematics. In this video we will see about what is present value of perpetuity and sinking fund. I'll also solve the questions from exercise 7.1 of CBSE Handbook. Now before seeing what is present value of perpetuity, we will see what are annuities and what is perpetuity. Annuities, we are familiar with this term from class 11. An annuity, it is a series of payments that are made at equal intervals. Now if we consider annuity, it is a series of payments that are made at regular intervals for certain period of time. Whereas if we consider this perpetuity, it is an annuity where the payments continue forever. It continues forever till infinity. So this is known as perpetuity. And now we will see the present value of perpetuity. In this present value of perpetuity, we have to remember these two formulae. One is present value of perpetuity of rupees are payable at the end of each period, and the present value of perpetuity of rupees are payable at the beginning of each period. So this formula is very easy. Present value of perpetuity of rupees are payable at the end of each period, the first being due 1 period hence. 1 period hence means after the first period. It is P is equal to R by I. And then the present value of perpetuity of rupees are payable at the beginning of each period. The first payment is due on the day of present value. It is given by P is equal to R plus R by I. So these are the two formulae that we have to remember as far as present value of perpetuity is concerned. Now the present value of perpetuity of rupees are payable at the beginning of each period. Here we can consider this annuity as an initial payment of R, then followed by a perpetuity of rupees R of this type. So that is the reason why we have R plus this perpetuity R by I, where R is the size of each payment and I is the rate per period. And now as far as the problems on present value of perpetuity are concerned, we can expect them for just 2 marks. Now we'll see the questions from exercise 7.1. Find the present value of a sequence of payments of rupees 80 made at the end of each 6 months and continuing forever if money is worth 4% compounded semi-annually. So here we are having one word, continuing forever. It means we have to find the present value of perpetuity of this rupees 80 if money is worth 4% compounded semi-annually. So first let us write what is given. The periodic payment, it is rupees 80, and then the rate per period I is 4%. It is compounded semi-annually, so divided by 2. So this is 4 by 200, or it is 1 by 50. So we have the present value of perpetuity P is equal to R by I. It is 80 upon 1 by 50, which is 80 into 50. That is 4000. Therefore, P equal to rupees 4000. So this is the present value of sequence of rupees 80, which is made at the end of each 6 months, and money is worth 4% compounded semi-annually and continues forever. So here writing what is given and the formula carries 1 mark. Substituting the values and getting the final answer carries 1 mark. A total of 2 marks. Next question. Find the present value of an annuity of rupees 1800 made at the end of each quarter and continuing forever if money is worth 5% compounded quarterly. So again here we have to find the present value of annuity of rupees 1800. So this is R, 1800, and the rate per period I is 5% compounded quarterly. So it is 5% divided by 4, or it is 5 by 4 into 100. It is 1 by 80. So the present value of perpetuity P is equal to R by I. It is 1800 upon 80 upon 1 by 80. 1800 into 80. So it is 1,44,000. So the present value of perpetuity of rupees 1800 made at the end of each quarter if money is worth 5% compounded quarterly is rupees 1,44,000. Next question. If the cash equivalent of a perpetuity of rupees 300 payable at the end of each quarter is rupees 24,000, find the rate of interest compounded quarterly. So here it is given the cash equivalent of perpetuity of rupees 300. So this is R. The cash equivalent means the present value of this perpetuity is given as rupees 24,000. This is P. We need to find the rate of interest that is compounded quarterly. So let us take, let R be the rate of interest compounded quarterly. The periodic payment is given, it is rupees 300. Present value of perpetuity is given, it is rupees 24,000. Rate per period will be, we have taken R as the rate of interest, so I will be R by 4. So using the formula, present value of perpetuity P is equal to R by I. We have 24,000 equal to 300 upon R by 4. Or we have 24,000 into R by 4 equal to 300. So R is equal to 3 by 60. It is 1 by 20 into 100%. Therefore, R is equal to 5%. So the rate of interest compounded quarterly, it is 5%. Similar question was given in the sample paper for 2 marks. Here again writing what is given and the formula carries 1 mark, and getting the answer for the rate of interest carries 1 mark. Next question. Find the present value of perpetuity of rupees 780 payable at the beginning of each year if money is worth 6% effective. So we need to find the present value of perpetuity of this amount, rupees 780. This is R. It is payable at the beginning of each year. And this is the rate of interest. So here we have to use the formula P is equal to R plus R by I. First let us write what is given. R is equal to rupees 780 and I is equal to 6%. 6 by 100. So the formula that here we have to use here is P equal to R plus R by I. Because here it is payable at the beginning of each year. So 780 plus 780 upon 6 by 100. So it is 780 plus 13,000 or it is 13,780. Therefore, P is equal to rupees 13,780. So the present value of perpetuity of rupees 780 payable at the beginning of each year is 13,780. Next question. The present value of a perpetual income of rupees X at the end of each 6 months is rupees 36,000. Find the value of X if money is worth 6% compounded semi-annually. So here the present value of some amount rupees X at the end of each 6 months is given as rupees 36,000. It is a perpetual income. So the present value of the perpetuity of this rupees X is 36,000. We need to find the value of X if money is worth 6% compounded semi-annually. So here given P is rupees 36,000 and I is 6% compounded semi-annually. So it is 6% by 2. or it is 6 by 2 into 100 is 3 by 100. Now P equal to R by I implies 36,000 equal to X by 3 by 100. We have to find X because R is X. This implies X is equal to 36,000 into 3 by 100. It is 1080. Therefore, X equal to rupees 1080. So these are the different types of questions under present value of perpetuity which can be expected for 2 marks. Now before seeing problems on sinking fund, let us see what is sinking fund. A sinking fund is a fund established by a company or business entity by setting aside revenue over a period of time to fund a future capital expense or repayment of a long-term debt. So it is the fund which is accumulated for the purpose of paying off a financial obligation at some future designated date. Say for example, if a father wants to set aside some money for the child's education or for the child's marriage, then that can be done by setting aside some amount at equal intervals over a period of time, so that at the end of that period, a lump sum amount will be accumulated. That fund is called sinking fund. And now as far as sinking fund is concerned, we have two types of formula. Again, we have when the periodic payments of rupees are made at the end of each period, and another formula when the periodic payments of rupees are made at the beginning of each period. So we have two formula for sinking fund. How this formula is derived, all these things I have already made a video. The links are available in the description. If you are interested, you can check those videos. So now we will see the formula. The periodic payments of rupees are made at the end of each period required to accumulate a sum of rupees A over n periods with interest charged at the rate of I per period it is given by. Is given by this formula. A equal to R into S at an angle n for I rate per period. This is the notation which is usually used in actuarial science. The formula for this is nothing but it is 1 plus I the whole raised to n minus 1 upon I. So we can write this as A is equal to R into 1 plus I the whole raised to n minus 1 upon I. So using this formula, we can find R when A and I are given. So this is the formula when the periodic payments are made at the end of each period. When the periodic payments of rupees are made at the beginning of each period, that is required to accumulate a sum of rupees A over n periods with interest charged at rate I per period is given by A equal to R into S at an angle of n plus 1 for I rate per period minus 1. So here S at an angle of n for I rate per period is 1 plus I the whole raised to n minus 1 upon I. If it is S at an angle of n plus 1 for I rate per period, it will be 1 plus I the whole raised to n plus 1 minus 1 upon I. So we can write it as K equal to R into 1 plus I the whole raised to n plus 1 minus 1 upon I. There is 1 minus 1 outside. We have to remember this. So this is the formula when the periodic payments of rupees are made at the beginning of each period. Where R is the size of each installment or payment, I is the rate per period, N is the number of installments, and A is the lump sum amount to be accumulated. So these are the two formulas that have to be remembered as far as sinking fund is concerned. For this year in the sample paper, question on sinking fund was given for 3 marks. So we will see the sixth question, continuing with the exercise question. If you need rupees 20,000 for your daughter's education, how much must you set aside each quarter for 10 years to accumulate this amount at the rate of 6% compounded quarterly? So the amount that is needed at the end of 10 years, it is 20,000. So this is A. How much we have to set aside? So we have to find R. For the time period is given, it is 10 years. To accumulate this amount at the rate of 6% compounded quarterly. So I will be 6% since it is compounded quarterly divided by 4. So here let us assume that the amount is set aside at the beginning of each quarter. So let R be the amount deposited at the beginning of each quarter. A is given as rupees 20,000. I is 6% upon 4. It is 0.06 by 4 or it is 0.015. Then N is 10 into 4. Here N is the number of installments. So here each installment it is made at the beginning of each quarter for 10 years. So N will be 10 into 4. It is 40. So using all these, let us find the value of R. Now we know the formula. We have A equal to R into 1 plus I the whole raised to N plus 1 minus 1 upon I minus 1. Here when the amount is deposited at the beginning of each period, then we have to use this formula. So this implies 20,000 equal to R into 1 plus I is 0.015 the whole raised to N plus 1. N is 40, N plus 1 is 41 minus 1 upon 0.015 minus 1. So from this we get R into, here we have 1.015 the whole raised to 41, it is 1.841 minus 1 upon 0.015 minus 1. So this is 0.841 upon 0.015 minus 1. Now this when we divide, we get it as 56.082. So 20,000 is R into 56.082 minus 1. From this we get R as 20,000 upon 55.082. 56.082 minus 1 is 55.082. So R will be 20,000 upon 55.082. This when we simplify we get it as 363. Therefore R is equal to rupees 363. So if a sum of rupees 363 is allocated at the end of each quarter for these many years, 10 years, then rupees 20,000 will be accumulated when the rate of interest is 6% compounded quarterly. Moving on to the next question. To save for child's education, a sinking fund is created to have rupees 1 lakh at the end of 25 years. How much money should be retained out of profit each year for the sinking fund if the investment can earn interest at the rate of 4% per annum? So here the sum accumulated is rupees 1 lakh and at the end of 25 years the rate of interest is 4% per annum. We need to find the amount which should be retained out of profit each year. So let us take, let R be the amount deposited at the end of each year. Then A is given as rupees 1 lakh. N is 25 years. I is 4%. It is 4% per annum and we have to retain this amount are out of profit each year. So we have I as 4% itself. It is 0.04. So we have A is equal to R into 1 plus I the whole raised to N minus 1 upon I. Here since we have the amount should be deposited at the end of each year, we have this formula. A is 1 lakh equal to R into 1 plus 0.04 the whole raised to 25 minus 1 upon 0.04. If we cross multiply, we get 4000 equal to R into 1.04 the whole raised to 25 minus 1. Or we get 4000 equal to R into 1.04 whole raised to 25 is 2.6658. 2.6658 minus 1. So from this we get R as 4000 upon 1.6658. Now this when we simplify, we get it as 2401.25. Therefore, R equal to rupees 2401.25. Similar question was asked in the sample paper for 3 marks. So here writing what is given and the formula carries 1.5 marks. Then substituting the values and getting the final answer carries 1.5 marks. So total of 3 marks for such questions. Moving on to the next question. A machine costs rupees 1 lakh and its effective life is estimated to be 12 years. A sinking fund is created for replacing the machine by a new model at the end of its lifetime when its scrap realizes a sum of rupees 5,000 only. Find what amount should be set aside at the end of each quarter out of the profits for the sinking fund if it accumulates at 5% effective. So here it is the cost of the machine is given and its effective life is estimated to be 12 years. At the end of its life, at the end of 12 years, the machine is worth rupees 5,000. So we need to find the amount that has to be set aside at the end of each year out of profit so that the fund accumulates 5% effective. So although the machine costs rupees 1 lakh, we have a sum of rupees 5,000 at the end of 12 years. As a result, the accumulated sum is only 1 lakh minus 5,000, which is 95,000. So let us take, let R be the amount deposited at the end of each year. So A will be 1 lakh, or let us write cost of machine minus scrap value So it is 1 lakh minus 5,000, which is 95,000. This is A. And next we have N. N is the number of periodic payments or number of installments. It is 12. And the rate of interest is 5% effective. So here the amount is allocated at the end of each year. So N is 12 and I is 5%, or it is 0.05. So we have the formula A equal to R into 1 plus I the whole raised to N minus 1 upon I. This implies 95,000 equal to R into 1 plus 0.05 the whole raised to 12 minus 1 upon 0.05. So if we cross multiply 95,000 into 0.05, it is 4,750 equal to R into 1.05 the whole raised to 12 minus 1. 1.05 the whole raised to 12 is 1.7958. 1.7958 minus 1. So it is R into 0.7958. So from this we get R as 4,750 upon 0.7958. Now this when we simplify, get it as 5968.8. Therefore, R is equal to rupees 5968.8. So the amount deposited at the end of each year should be rupees 5968.8. Again, writing what is given and the formula carries 1.5 marks. Remaining steps and the final answer carries 1.5 marks. Next question. Suppose a machine costing rupees 50,000 is to be replaced at the end of 10 years. At that time, it will have a salvage value of rupees 5,000. In order to provide money at that time for a machine costing the same amount, a sinking fund is set up. The amount in the fund at that time is to be the difference between the replacement cost and salvage value. If equal payments are placed in the fund at the end of each quarter and the fund earns 8% compounded quarterly, what should each payment be? So here we have a machine costing rupees 50,000 that has to be replaced at the end of 10 years, and at that time it will have a salvage value of rupees 5,000. And it is also given the amount in the fund at that time is to be the difference between these two, replacement cost and the salvage value. Replacement cost is the same because it is given the company has to obtain a machine costing the same amount. So the amount in the fund should be the difference between this amount minus 5,000. Now we have to find the size of each payment. If equal payments are placed at the end of each quarter and the fund earns 8% compounded quarterly. So let us take, let R be the amount deposited at the end of each quarter. The accumulated sum A will be replacement cost minus salvage value. So the replacement cost is 50,000 and salvage value is 5,000. So it is 45,000. And then we have the number of payments that should be made. We need the machine to be replaced at the end of 10 years and the payments are made at the end of each quarter. So N is 10 into 4, 40. And I is, interest is 8% compounded quarterly. So I is 8% by 4. It is 0.08 by 4, which is 0.02. So we have A equal to R into 1 plus I the whole raised to N minus 1 upon I. So here A is 45,000 equal to R into 1 plus I is 0.02. The whole raised to N is 40 minus 1 upon 0.02. So here this, when we cross multiply, we get 900 equal to R into 1.02 the whole raised to 40. It is 2.208 minus 1. This is R into 1.208. So from this we get R as 900 upon 1.208. This when we simplify, get it as approximately 745. Therefore, R is equal to rupees 745. So this is the size of each payment. A sum of rupees 745 should be deposited at the end of each quarter so that the sinking fund will have an accumulated sum of rupees 45,000. I hope this video was useful for you. In my next video, I'll continue with the handbook exercise questions on financial mathematics. If you have not subscribed to my channel, please subscribe. Thank you for watching.